Okay, great. Elixir. What a crowd. You don't like Java anymore, I guess? So, before we start, one question. Who has used Elixir before? Awesome. Great. Is it installed on your Mac? Is it installed on your Mac? Ah! Damn. Okay, good. So, Elixir first, Java guys. That's me. I'm David. I'm from Düsseldorf, and you can see my amazing fighting skills. I assume I'm a better programmer than fighter. I work for a consultancy in Germany, for Senacor, where we do basically projects for banking industry, insurance, moon rockets, stuff like that. What's in it for you? I only have got 3 goals. And that is, first of all, I want to whet your appetite for Elixir. I love Elixir. It's the best thing since the sandwiches at lunch. Sorry, it's even better. Then I will show you some of its amazing features, which I think are pretty unique to Elixir. And last but not least, I will try to do some live coding. Actually, I hate live coding. It never works. It always fails. But let's hope. Hope dies last. Who thinks there's something to be learned here that we'll actually use? Anybody? Wrong. So why should you listen nevertheless? The fact I tend to learn new languages all the time. I like learning new languages, Kotlin, Elixir, Clojure, whatever, because it's like learning new languages, natural languages, like learning Spanish. If you learn things from another company, for another community, for another culture, it just opens your eyes. If you know you're Chinese, I hope it's Chinese, it's like they compare it to a window where you can look out into new communities, get new ideas, see how other people deal with problems. That said, buyers beware. I am the Jon Snow of that topic. You know what that means? You know Game of Thrones, yeah? No? Nobody? Jon Snow knows nothing. And I'm Jon Snow, just without the apps. So Elixir is nice and awesome, and Erlang OTP is great, but the topic is so huge, and I've just started a year ago developing on that platform, so I guess I know more about Java than Elixir, so be nice to me. That said, this won't be a README. So there won't be any slides where I tell you, oh, the functions are defined like that and lists like that. No, we jump headfirst into code, and I think you will understand. Who knows that acronym? YAPL. Yeah? Exactly. We play this game with JavaScript developers where we go to bed and we get out of bed the next day and 3 or 4 frameworks come into life and a couple of others had already died. The same is, I think, with programming itself. This is the Cambrian explosion of programming languages. Kotlin, Clojure, Frig, whatever. And so why should you even bother with Elixir? Elixir is basically the combination of those 3. What's the first symbol? Are there Ruby developers here? Yeah, you are a happy man, so are you. The second is obvious, is Erlang, OTP. And the third one is? Yeah. So why is this a good thing? Why is it a good thing to combine those 3? So I will start with Ruby. This is basically the architectural layout of Ruby. Ruby is pure joy. Being a Ruby developer is like watching all episodes of Bob Ross painting his pictures. It's pure joy. Mats, the designer of Ruby, he had just the impression of programmer happiness. That means the program should help you and not the other way around. If you think of Scala, and I like Scala, but if you accidentally write something in the wrong way, Scala punishes you. You are stripped of your clothes and you get to whip. Ruby, on the other hand, it tells you, oh, you typed this, maybe you meant something other. And that's the power of Ruby. Ruby was successful in spite of its terrible performance. And that's who knows him. Who's old enough? Yeah, great. 80s, go. That's He-Man, the most powerful man in the universe. He is incredibly powerful, and that's Erlang. Who has ever heard of Erlang OTP? Okay, great. So everybody knows what it is. It was developed around 86 by Ericsson because they had some issues programming their switches. Because switches for telecom, you can't just turn them off because there are many phone calls going over that switch. So you can't just turn it off and update the software. How to do that at real time? How to keep systems stable? Erlang OTP solved those problems 95 with the OTP, Open Telecom Platform, although today it's just called OTP because it's not restricted to telecom. Everything we want to achieve by going into microservices, by going distributed, He-Man, he has solved our problems. He knows how to do this. And last but not least, this is the Church of Closure. Rich Hickey is always right. Yes, exactly. Why do I think that? Because Closure is one of the best designed languages I've ever seen. One can easily see that the JavaScript guys, they had 10 days or something around that, and he designed the language, I think, in a year or two, so really slow, well thought out. And Elixir combines features of all those three platforms and many more. So if Ruby is so awesome, and Elixir and Erlang is so immensely powerful with all these muscles, and Closure is so well thought out, most intelligent language ever, why Elixir? Well, Ruby scales, but badly. If you try to scale Ruby, this will be a terrible time for you. And everybody who has ever done some Rails development can easily agree, I think. Erlang, if you've ever seen Erlang code, if you've developed in Ruby or in Java even, then Erlang code is punishment. The way it's really the way Erlang does handle its lists, it's basically Prolog, only worse. So it's no fun to work with that tooling, to work in that language. And Closure, why shouldn't you use Closure? No reason. If you don't use Elixir, get out, buy a Closure book, get going. Joe Armstrong, that's the creator of Erlang. He tried out an early version of Elixir for a week or so. And I won't read it because you can read yourself. He's impressed. So if the creator of a language, if Brian Götz would post on Twitter, Scala, well, that is really good, that would be a statement. Haven't seen that yet. Joe Armstrong, on the other hand, he thinks this is good. So why is Elixir so awesome? It's programmer focused. Everything in Elixir is about you. Its error messages are human readable. It's not like, blah, you forgot a semicolon. No. You will see in the demo when we do oh God. No. Hate that. So it's all about you. They even go so far that José Valim, the creator, said, if you find a section in the documentation that you do not understand, then this is a bug. Just tell that to our Java guys. If I look at a completable future and read the Java doc, next day I'm crazy, basically. So, second of all, it combines the power of OTP. You will see that later. You have no idea what you can do with base Erlang, and Elixir makes using that really easy by using Ruby features. It's a functional language, so right on to the hype, but in a pragmatic way. That means, at least from my perspective, if you do functional programming, sometimes it feels a little bit over the top and bothersome. Not so with Elixir. Everything is immutable. You can't change anything, but you can rebind variables, as you will see later. And that's a really good thing once you program. And Elixir comes with a standard toolset. So once you install Elixir, you don't run around and ask yourself, Maven, Gradle, Rake, SBT, what I'm going to do? No, build tool included, package manager included, test framework included, everything is included. Obviously, you can do your own thing, but the stepping stone to get started in that toolset is really low, so productivity right from the beginning, without frustration. So for me, Elixir is Jean-Claude Van Damme. In his old days, not now. Although he's still fit, actually. All the muscle, all the power, but the flexibility that we need. And the great hair, I have to say. So who knows what Erlang OTP actually does? Only one. Who's using on his phone 3G? Anybody? Yeah. You're probably using Erlang. Erlang is still driving round about half of the world's texting, phone calls, everything. And on the other hand, if you say, oh, old infrastructure, okay, think about WhatsApp. Have you ever seen WhatsApp as a service not available? I think there was only one instance back then when they merged with Facebook because they did some nasty things to their tooling. Other than that, if you look at WhatsApp, always there. If you look at RabbitMQ, always there, Erlang. Erlang OTP is the language and the virtual machine. Erlang does not run natively. Just like Java is compiled to JVM, Erlang is compiled to the so-called Bean. That's the Ericsson virtual machine. Highly optimized for distributed computing, highly optimized for tiny processes. Second of all, we have those tools. There are tools, like for example, if you develop microservices in Java, the first thing that comes to mind is, how the heck am I going to monitor those things? How can I look into my system? Erlang OTP has those tools right from the start. Obviously, there are tons of libraries for crypto, for everything. And last but not least, what's most important to me is the set of patterns. Is there a set of patterns actually in the core of Java? Yeah, I think there's one. There's this add singleton annotation now at JE. Yeah? Anybody uses that? No. Erlang OTP with its patterns defines patterns for supervision, for distribution, for messaging. And if you approach an Elixir or an Erlang developer and you tell him, whoa, my messaging subsystem stopped working, he knows what you mean. So there's no fussing around, do you use the supervisor implementation from that framework or that framework? It's all in the language. And Elixir takes all this fun and games and bakes a nice big cake. So easy to eat for everybody. So, what's a common use case? I thought about programming Fibonacci numbers, but then I thought DevOps, the only issue I have at DevOps is the food. So I'm always hungry. So in this case, we want to code a pizza parlor. And the idea is, I just call a pizza parlor, say, here's my money, give me salami pizza. And presto, we will get the salami. So I will try to do this actually. Can you read this? Yeah, I guess so, yeah? Okay, the first thing is creating a new project, and that's really easy. It's just this mix, and I will provide this sub because of reasons. So I say mix new. And we'll call this thing pizza demo, okay? And as you can see, directories get created, nothing fancy. Everything that using an archetype in Maven would also do for us. But the tiny bit, basically the sugar, is this section. It tells you directly, dear developer, the next step should be go into this thing, run your tests. And this is what we're going to do. Bye-bye. Great. So, I don't know, I think Sublime cannot actually scale those things. Oh, it's readable, I think, yeah? You can see the directory structure that is created. It's a standard directory structure. And there's this config folder, the library folder, and the test folder. And guess what? The tests go into the test folder. Crazy. The configuration into the config folder, and everything else goes into the library. So let's just create our pizza thingy. How would we call this? Let's say pizza. Yes. So everything has to be in a module in Elixir. That's just a fact. Nothing can live outside of a module. And what's the first thing you need from a pizza service? It's the menu. Otherwise, you don't know what you can order. So we create a menu. And this is just the syntax for creating a hash map. Because right now we are lazy. Map is our good friend, as you all know. And we just create a map where we say we have pizza tonno, for example, and what's the price for pizza tonno? €10.50. And salami. Let's say it's cheaper. That's all. We can go to the console and we can test this directly, not mix. Who knows what a REPL is? Yeah, you're looking forward to Java 9? Yeah. The rest of the development world already has that. Elixir also. So we are now in the REPL and we can do everything here. So I can create compile errors. I can ask it to inspect certain data types. I can ask for help. I can, for example, if I don't know, oh, I nearly forgot. We have to please the demo gods. Sorry. Great. So that's out of the way. We needed that. So we can do everything we want basically in the REPL, and it's the best way actually to get started and learn the language. Okay. So we know we have created this pizza service with the menu. Who's amazed? Really? God. So what we can do is we can store it, obviously. Let's say we have this thing, and now A contains that. I can also do something like this. That's not so functional, is it? There was this A, and I can even do this. Ooh, strange. But what I also can do is same thing. Because that is pattern matching. If you know pattern matching or structural decomposition from other languages, Elixir takes this a little bit further. Everything is pattern matched. There's no assignment. It's not just a rebinding. So in this case, in this IEX number 14, I tell Elixir, try to check if you can somehow match A to the string FFF. And A is FFF, so no problem there. If I said Devox, whoa, can't match that because A doesn't match that. This is something you have to get your head around, okay? So back to the code. Now we have our menu. And we want to order a pizza. And we want to order it by name, okay? So the easy thing to do is, and I will do the easy thing because I'm really lazy. We just get the map and we take out whatever is stored under the name. And this can be, for example, nil, if we do not find anything. In that case, we would just return error, let's say no search pizza. I think that's understandable, and that's a common idiom, basically in Erlang and Elixir. You always return tuples, where the first element either is error or okay. That indicates everything went wrong. And why that is the case, I will show you in a second. And if we find something, this will be the price, I guess. So we can say, okie dokie. And once again, we return a hash map where we say the price is price. And we give a nice message. Enjoy. Clear? I guess so. Let's try this out. and I don't have to restart. I just recompile that class. Everything, this module, everything is there. So once again, pizza service menu, nice. Pizza service, order pizza, awesome. If I say salami, nice. And if I say bratwurst, we don't find that. And if you think of the pattern match that I showed you a few minutes ago, how you would use this is by pattern matching. You would say, okay, and we expect a price and whatever. What? And now, that's the way you deal with pattern matching in Elixir. You say on the left-hand side, this is the structure I expect, and if it doesn't match, it fails. Think about how error handling works in that case. Let's say we have that pizza. And that's the idea. I will show you later. We do not code fallbacks where we deal with error and, okay, if we don't find the pizza, then we fail. That's the basic idea. So that's basically our code at this point. Nothing fancy. So I told you about Erlang, and we didn't use any Erlang so far. We used Erlang because Erlang is underneath, but we didn't use any specific features. There's this article where some guys claimed that they built a system with 9 nines availability. Who of you has ever developed a system with 6 nines or 5? 6 nines? Whoa! Kudos. 9 nines is, I don't believe the story, they told it, but I don't believe it, but we can do this actually. But in this case, we have to think about resilience and reliability, because of course their system was not fault-free for all this time. It failed, but it was available. Maybe a subsystem crashed, but it got recovered. So what are the pillars? First of all, we have to isolate. And I think microservices. Yeah, then everything will fall in place. We have isolated processes. Isolated means shared nothing. And they just communicate by message passing. The second pillar is, if we have so many processes running around, I, as an ops guy, I cannot recover them manually. So there must be some means of automatic fallback, of automatic monitoring, of automatic recovery in case of failure. And last but not least, the programming model, for me to be productive, must not be EGB 2.1 remote interfaces, because those suck. The programming model should be independent of distribution. Obviously, as a developer, you must be aware of distribution because of latency and stuff, but the programming model should not be. And Elixir has 2 power tools I want to show. First of all, the GenServer, and second of all, the supervisor. The problem with the way we as a community code our services is that we stuff everything into one heavy process. Even if we say we use something like Netty, where we can reuse the thread it's running on in an intelligent way, nevertheless, we have one giant process with many different kinds of computations and maybe even some shared states somewhere lying around. And the bad thing is, when something fails, everything fails. And then you get called at 9 o'clock in the evening on a Friday night and you have to debug your code, which everybody likes. Erlang OTP has been optimized for tiny processes. I have a Raspberry, the old one at my house, and I'm easily able to run 10,000 processes, Erlang processes on that machine without it stuttering in the least. The basic abstraction is the generic server. That's GenServer. I think they ran out of letters. And each process, each GenServer consists of its own mailbox, its own computation, its own state. Completely shared nothing. And the idea is that the outside world just sends a message to that process asynchronously. So basically, if I want to order a pizza, I send you my order, and that order obviously gets consumed synchronously. That means the message arrives, gets stored on a queue, and you all know message queuing, I guess, today. It gets handled, and then maybe we send a reply. That's the idea. In pseudocode, we would write it like this. We loop. Erlang calls our process with the function loop, with the current state. Then our process waits for the next incoming message, handles it, and maybe sends a reply. I would always send a reply because courtesy, but you must not, you need not. And last of all, it loops again with the new state. This is quite good. It's the last statement. That means we are tail recursive. And that means what? Any idea? Okay, exactly, no stack. So there's no real recursion going on. It's just basically a go-to statement. And go-to statements are awesome, as we all know. So we move from heavyweight processes to a world of tiny processes. And this does not add any overhead. So what we are going to do is we are moving animation. We are moving our message-driven pizza parlor to something that can send an order for a pizza, and it gets basically handled by the pizza service, and the reply is sent to the consumer. So let's see how we would do this in Erlang, in Elixir. There's actually not much what we have to do. We just say, use GenServer. And then we implement a couple of callbacks. The first callback you would usually implement is this start link, where we actually start our process. And start link needs the module, the state, and you can also provide a name. That's what I am going to do. Let's call it DevOps. No, let's call it pizza service. Let's use the real example. If we try this out in the REPL, once again, we recompile this pizza service, and I say pizza service. You can see it. Something has actually been done. And I can look at this. I can say, this is the monitoring tool that comes with Erlang. And if I look at, you can see all the applications that are running. You can see our pizza demo here, and there should be a pizza service process somewhere there. So that has been created already for us. We can't do anything. If I say GenServer, for example, call pizza service, and we send it a message like ping, then exactly ping will happen because we can't handle that message. So let's handle that message. Handle call is the callback. Handle call is, I have to concentrate, live coding sucks. Whenever a message is received, one of your handle call implementation gets called. And there can be many in this GenServer. And once again, this is where pattern matching comes into place. Let's see how we send a message. Let's say we send a pizza order. We would say GenServer call with the message pizza and the pizza name. Then this is exactly the message that will be handled by our call. So we copy this here. And now we have the pizza name because it gets pattern matched by Elixir, okay? And we need to reply somehow. And we say reply message, for example, awesome. And we don't care about the state right now. We can try this out directly. Once again, we recompile the pizza service. And we say pizza service, you have to start it again because it was killed. And now I can say pizza service. Awesome. There's much going on behind the scenes, and you can see this by actually tracing the messages. So Elixir will tell you that there was a message, pizza tonno, sent from one process to the other, and the other process replied with, awesome. But that's not what we wanted to do. We wanted to order a pizza. And we have this order pizza down below. And the usual idea would be to say order pizza, pizza name, something like this. But that's also not the way Elixir thinks. Elixir thinks about transformations. As we don't change things, we only transform things. And that's why they actually built this tiny little pipe operator. That's just basically syntactic sugar. What I typed before was exactly the same. But if you have multi-methods like A and B and C and D, and instead of that you write D, C, alphabet, not my strength. If you write it like this, then this tells a story. You can read it from top to bottom. You say A gets transformed via C, gets transformed via B, gets transformed via A. So that's the basic idea. So we order a pizza, and we have a response in that case. And we can send back just that response. I recompile this. Send was the name, yeah, I forgot. See exactly what expected. And if I say salami, and what was Brat? Sauerkraut. I'm a German, there must be some sauerkraut in here. And that's all you have to do, basically, nothing else. Bam, tiny process. And if you wanted, you can start thousands of this tiny process on your single machine without any load that you would expect. Resilience. Is that resilient? No, it is not. Because our process is running, and if I say, for example, GenServer, our good friend, the peng message, it's dead. It died. And you get called 9 o'clock Friday evening. I can say, where is my pizza service? And the next time it's gone. So obviously what we need to do, we need to go back into our code. So there's this peng message, yes? So we say def handle call, peng. No, that's not the reason. That's not good. We won't do that. That's definitely the wrong way, because the paradigm of Elixir is, have you tried turning it off and on again? Who watches IT Crowd? So you know that. Huh? You might have heard the more serious expression, let it crash. The idea is really simple. What happens when, for example, this monitor goes haywire, runs amok, and the color is broken? I turn it off, and I turn it on. If your window shields, your automatic window shields in your car doesn't work, you turn the car off, and you turn the car back on. It's a simple pattern, and it works. If the error is transient, and you turn the thing off and on again, chances are that the error will go away. If it's a persistent error, it means you didn't test your code, there's some maybe the database is in flames, who knows, then the error will persist, obviously. But in general case, if there's a transient error, letting it crash is totally fine, which is a great excuse to go home early. So what is the case now for us? The pizza parlor goes boom, and our nice customer is really sad, and we have only to rely on DevOps lunch. And like at work, in order to keep us developers happy, we need some supervision. We need a manager that watches us. Yeah? Is there any supervisor here? A team lead, somebody? Yeah? Okay, so you know you can only rely on your workers by watching them. Yeah, what? So we know there might be dragons down there. There might be something broken. The high-risk operation, the oven for the pizza may go up in flames. So the idea is we insert a supervisor. And the idea is really easy. It's like a parent-child. The supervisor watches its children. So it looks at its sub-processes, in this case the pizza parlor, the oven, and if that thing explodes, it just creates a new one. And you go, yeah, it's so easy. That's the way we should think about processes. If you think at Docker containers, that's the way Docker containers behave. If a Docker container failed, you remove it, up goes the next instance. And Erlang had this for 30 years. So now I will show you the extraordinary process for inserting this into Elixir. We only got 25 minutes. Whew, let's see if that's... So we have our GenServer here. So the first thing I have to do is I have to insert the logger so that you can actually see anything. Up and running, so that when we start this thing, we can actually see something. So, and then, now the real work comes. If you go into the application, you will see this little section where the children are defined for this supervisor. And all we have to do for this to work is we say worker, pizza, service, no state. That's all. And if I go back, you can see directly the message EP up and running. Yeah, saw that? And if I now say GenServer call pizza service, and you see that sometimes I forget the parentheses, doesn't matter very easily. So I say pizza service call, ping. Huh? No, it's expected because it was restarted faster than the error message was actually logged. Yeah, it's cool. And that's all. It's nothing more. That's the basic idea. You just create trees of supervision where you put the risk to the bottom of the tree. If you have some business logic that doesn't rely on external state, on files or stuff like that, no problem there. But you have stuff like reading a database, reading some external data store, reading SAP, whatever there is in your backyard, then that's the point where you push down the risk, right down. And supervisors can supervise other supervisors so that you have a cascading escalation route. Like in your enterprise, if something goes wrong, the manager reports back to the next manager and up the chain until the problems are discussed away. But this is just a tiny, tiny bit. I would love to do a workshop now with you for 8 hours and share my love for Elixir with you. For example, who thinks that the way we do polymorphism in Java is really well designed? I hope nobody. I think, he wanted to raise his hands. If you think at Clojure has this amazing idea of protocols. It's not simply Clojure, other languages have this too. But the idea is that you can actually introduce after the fact polymorphism. In this example, I define the behavior, string characters, that's a toString method. Just think how you would do this for a final class in Java. You have a final class in Hibernate and you want to add a toString method. In general, you would use reflection or you would create a decorator class, something like this. In Elixir, you can easily extend existing classes by using protocols. Then this macro system. Any Lisp fans here? Okay, great. Lisp is awesome. There's a sentence that every system that gets complicated either migrates towards Lisp or uses Lisp. So, and one of the reasons why Lisp and Clojure are so awesome is because of their macro systems. And if you think of, for example, JavaScript has this somewhat too, but not in a real sense. This is not code eval. This is compile time macros. This is not your C++ macros. What I'm doing here, I'm defining a new keyword, unless. And wherever I use this macro, unless, this thing gets inserted. And I would argue that although also this is a macro, this is nevertheless readable. It's completely understandable what gets unquoted and what gets quoted. And the meaning behind that should be obvious, even if you're just Java developers and not Elixir developers. And you have to think about that most of Elixir has been developed using Elixir's macro system. So that's eating your own dog food for you. Yeah? Then you have this thing. Just think about online games. Just think about you have a first-person shooter where each round of shooting takes 10 minutes. How do you upgrade such a machine? Yeah, of course, I know how we upgrade this. We put a public notice on our webpage. Dear friends, we will be down between 0 o'clock and 2 o'clock in the morning. Come back afterwards. With Elixir and Erlang, you can do this zero downtime hot code replacement. That means that you release a new version of your application, and this callback gets called in your process. So there's this version flag, and you can migrate the state of your process to the new version. Or migrate down, that's up to you. You can go up, you can go down, as you want. Actually, there's a great talk of some US guys who maintain a poker platform. And when you play poker, this is not predictably over. So the round can take about 20 minutes, 50 minutes, something like this. And they use that to upgrade their platform continuously, without any downtime. And then there's Acto and Phoenix. Phoenix is started as a web framework. Think of Rails, just cool and maintainable and an awesome experience. And Acto is something like a DSL for fetching data from a SQL. You can see an example here from Q and query, This is not an object relational mapper, don't take me wrong. This is basically a DSL for SQL. And the cool thing is that once again you can pipe this using the pipe operator. You can say video. Video is also a query because it's a database module. I pipe it into video alphabetical, and then I say repo, fetch everything there is. Easy and composable. Phoenix, on the other hand, it's amazing. You have to try it out to see actually what it does. It's started as a web framework with server-side HTML generation, which is really hip these days, I think. But now they've introduced a channel abstraction. A channel is an abstraction on top of WebSockets. And due to the fact that Elixir has this low-level, low resource-intensive process abstraction, you can fire up hundreds of thousands of these tiny processes. And if you think in the direction of MQTT over WebSockets, it's obvious that Phoenix might become the tool for delivering IoT applications. I hope that was enough buzzwords in one section. Yeah? IoT, MQTT, real-time. No, really. Phoenix, awesome platform, awesome. I nearly forgot. Who knows what CRDTs are? Conflict-free replicated data types. This is bleeding edge computer science. I think, not so bleeding edge, but the Java still looking for Java implementation. No, CRDTs is something that will become mainstream, I guess, in the next couple of months or years. And it has been used, I think, in Rabbit. Rabbit uses it internally, I think. And Phoenix, the next version, will use this for their presence subsystem. Just think about the question how you would deal with, you have a cluster and you have multi-devices, an Apple iWatch, a phone, and your computer, and you log into the system. Do you want multiple logins? Do you want a single login? Actually, you want multiple logins, but you want a single presence. And that's the abstraction that they are building around it. This is really, really well done. I can't explain it right now because we only have 60 minutes left. Check it out, read into it, because this is stuff that will come to our community in the next couple of years, I guess. So, should we all build everything with Elixir? I do. No, I'm a Java guy, so I have to use Java on my job, but if there's non-mission critical parts of our system, like infrastructure, like reporting, like convenience tools. Now I build them with Elixir. And we should Elixir all the things. That's the message. Just go to your work next week and say, David told me to delete all our Java code, and we install Elixir, and there we go. And you will lose your job. So maybe not. Oops, sorry. I think that Elixir nevertheless offers much. You have to go into the language. The language, you don't need books to learn the language. The language teaches it to yourself. You just start working and you discover one thing after another. It's not like you have to learn classes, type inference, collection framework, and whatever to get a simple example running. It's just straight out, do your thing. And of course, this wouldn't be a conference talk without mentioning cloud and microservices. The microservice problem is not there in Elixir. It doesn't exist. There's no discussion around let's build microservice, because the way things are delivered via processes and via supervision trees and stuff like this, that's basically the technical challenge of microservices. Not the organizational, how do I verticalize my team, but the technical challenges are just not there since 1995. And you can deliver actually your applications to the cloud. Our last innovation day in Germany, where we go into an office for 24 hours and we just code away, I built a Slack bot using Elixir and could deploy it without any fuss on Heroku, which was awesome. I had expected many problems because Heroku out of the box does not support Elixir. But there's the plugin available, so you can push it into the cloud. And I think Amazon AWS supports it. Erlang deploys too. So I think if you go into Elixir, use it, even use Erlang, read Erlang, see what Erlang does. You get new insights, even if you do not use it on your job. Even if you will never code one single line Elixir, there are many patterns, many solutions to problems that we as a Java community are rediscovering. And this makes me crazy. There are all those older colleagues, 50 or 60, they say, we've done it in the past, and it's true. Most of the problems we now face, okay, on a greater scale, more data and stuff like this, but nevertheless, they have been solved. There are clean patterns, which makes things easier. You talk about supervision trees, you talk about distribution, you talk about messaging, and they are all part of the core of Elixir. So there's no confusion whether or not you should do things. As I said, I think, and I cannot actually prove this, but I think this will be, Phoenix may be one key to develop applications for IoT with its WebSocket abstraction and the surrounding tooling. And what's most important to me is the community. This Elixir, it's like okay, if I would program in Elixir the whole day, I would be happy too. And there are a bunch of happy people. José Valim, the main creator, is as if he was on vacation the whole year. It's like that. And you can ask him questions at any time and he will respond at any time. The same goes for the Phoenix community, for everybody that is actually active in Elixir. So there's no boundary there. If you want to know more, I would actually just say go to the homepage, read the tutorial, start developing. It's completely sufficient. If I had to actually recommend 2 books, I'd recommend Programming Elixir. It's dated. It's not the most actual version of Elixir. But first of all, Dave Thomas writes awesome books. And second of all, there are a couple of exercises, so you can get started with them. You can get started with thinking in Elixir. And this other book, this Erlang and Anger, is an Erlang book. It's not an Elixir book. But it's about delivering highly distributed systems to production, letting them run for years and years and years, upgrading them in real time, upgrading them while the system is still on. Even as a Java developer, there's much to be learned in that book. So that's all from my side. Questions? No questions. This is good. No, one question. The question was if there is any interoperability between Java and Elixir. And actually, 1 week ago, I would have said, not that I'm aware of, but surprisingly, there is. There's a project that takes care of that. I don't know if it's production ready. So if you come to me, I can show you the name of that project, where you can actually call Java from Elixir and vice versa. But that said, would I do that? I'm not sure. It can be done. Otherwise, maybe it's more sensible to move to messaging, maybe plug a RabbitMQ in between or something like this. Sir?
Yeah. Are there application cases which are kind of hard to express with this because it has kind of a limited, or let's say a different set of what you can do and what you can't? For example, let's say you want to sort something.
Yeah.
And there's many sorting algorithms assume that you sort in place, which is mutability at mass.
Well, the question was if there's something where Elixir or this stuff is not suited to. Actually, that's a good example with the sorting algorithm, where you have an algorithm where it's expected to sort in place. But what does it mean to be sorted in place? If you put it down and you have these 10 elements lying next to each other, and you say, I swap 2 elements, for example. That's just new list, those things swapped. So I don't have to modify the original collection. You know what I mean? So this immutability is no problem in that case. Is there anything that can't be developed with Elixir? Well, I guess it's a general purpose language. It's Turing complete, so you can develop everything with it, I guess. So I can't easily answer that question. It's easier to say, for example, if you asked me if is there anything I wouldn't develop with Rails, that would be easier to say, because with Rails I have much more experience than with Erlang and Elixir, so I will tell you highly scalable, maybe not. With Erlang and Elixir so far, half the world's telecommunications running on this stuff, so it would be hard to find something, at least in my work environment, that has higher requirements than that. Okay? No other questions? So, thank you very much.